All right, so today we're still learning in chapter 5 about triangles. Okay, so we've talked about points of congruency, correct? We talked about perpendicular bisectors, we talked about angle bisectors, and by the way, for your quiz and on the test, I would really take the time, everyone look at me right now, okay? I would really take the time and really go over your notes and the problems on the notes and your homeworks from lesson 5.1 through 5.4. Now remember, 5.2 and 5.3 were together. I would really take the time and study them. This is your last quiz, okay, that you're gonna have, and your test is next week. It's the last hurrahs, okay, before you do this. This is not on your quiz tomorrow. You guys with me on that? Okay, so first of all, let's do a quick review. Okay, do you guys remember the triangle exterior angle theorem? Remember this one right here? Do you remember the rule that saved us a lot of time? What do we know about the measure of angle 1? How can I find it quickly? Yeah, the measure of angle 2 plus the measure of angle 3 adds up to it. Remember they had special names, correct? This was called the exterior angle, and this one, oh, these two were called your what? Remote interior angles. Now I want to ask you a common sense thing. If those two smaller angles add up to the larger one, is this true? Is the measure of angle 1 greater than the measure of angle 2? Question, should the whole be greater than a part? Okay, look at this one. The measure of angle 1 is greater than the measure of angle 3. Should the whole be greater than one of the parts? Does anyone see common sense on this one? Okay, so today we're doing comparisons, all right, inequalities. So using that, we have, of course, a corollary to the triangle exterior angle theorem. Remember, a corollary is a closely related one. But here's the common sense. The exterior angle, its measure is going to be greater than either one of the remote interior angles. Profound, isn't it? Anyone think common sense? I hope you think that's very much common sense. So let's just fill in the words, and then we're going to move on with that one. The measure of an exterior angle triangle is greater than the measure of each of its remote interior angles. All right, yes, some of you are going to call this the common sense theorem. I totally get that. But hopefully visually it makes sense as well. Common sense? Awesome. And doesn't it really do make sense? Look at, you have two acute angles and then you have your exterior there. It really does make a lot of sense. All right, the next two theorems, I'm going to tell you right now, I name them, okay? You have to understand that for time-wise today, I can't go into my note. I normally teach this on a block day, so please forgive me on this. But does anyone remember the story of Goldilocks and the Three Bears? Okay, the gist is that Goldilocks breaks into the house, correct? She basically steals food and destroys property. Okay, is basically what Goldilocks does. Yes, I just did a political correct version of this. But the thing is, what was so special about the Three Bears? Remember how Papa Bear was all big? And everything was Papa Bear size. So if Papa Bear's big, everything was big, right? Mama Bear was the middle-sized bear, right? And everything was medium-sized, and everything was just right for her. And then you had the baby bear who was small, correct? And who was, everything was small and, you know, perfect for Goldilocks to steal and destroy and eat. But anyway, everything was small for baby bear. So weren't there three different sizes of bears? And everything was proportional to those sides. Here's the question. How many sides does a triangle have? 3. How many angles does it have? Do you think the length of a side of a triangle affects the measure of the angle opposite of it? Yeah. So why can't we name, okay, this is not going to be probably said by any other geometry teacher, but I'm going to call this a theorem. So I want you to remember everything goes in threes. This is called the Three Bears theorem. I knew you would giggle, but you're going to remember it, okay? The Three Bears theorem is basically saying, should the size of a side affect the measure of the angle opposite it? Now remember the word opposite. Remember here AB and AC should be opposite. Guys, you've already used this many, many times in math. Look at this. What if I have a right triangle right here? This angle's 30. This one's 60. All of you can tell me what the longest side is. What's the longest side of a right triangle? What's the largest angle in that triangle? Look at, the largest angle is opposite the largest side. 3 bears, Papa Bear side, okay? The biggest angle is opposite the biggest side. So this would be the largest side, and that's the largest angle. No way. Okay, now look at that triangle. What's the smallest angle? The 30. Look at which is the shortest side. That's the baby bear side. The baby bear angle is opposite the baby bear side. Everything's just right, okay? It works that way. All right, where's the 60 degrees? Is that mama bear? Yeah. Okay, mama bear is going to be opposite the middle length side. I know, Sophia, you're laughing, but doesn't that make sense? Think about it, using your hands. Smaller the angle. What about, let's say I have a magic fingertips right here between my 2 fingertips. There's a side. Everyone see the imaginary triangle? Smaller the angle, smaller the what? Bigger the angle? Do angles and sides affect measurement? Yes! 3 Bears theorem. So let's write it down and understand no one else is going to call it this. But to me, it just makes sense. Everything matches. 3 bears, 3 sides, 3 angles. Wow. Voila. And don't be surprised if I do something and I just call it the Papa Bear side without thinking. So please forgive me if I do that. But it's just kind of, I've done this for so many years. It just comes out and I'm like, oh yeah, the longest side. Sorry, not Papa Bear side. So forgive me on that. So let's write this down. Here we go. Are you guys ready? If 2 sides of a triangle, now here's a new one, are not congruent, then the larger angle is opposite the longer side. So here's the deal. We know this one is the bigger side. This one is the smaller side. So which angle has to be bigger? Angle C. So the measure of angle C is going to be greater than the measure of angle A. Now, notice it doesn't say all 3 sides, but can I imply that for all 3 sides? If I know, but here's a cool thing too. You've already done this too. Guys, isosceles triangle theorem. What if 2 sides are the same? What do you know about their angles? They're the same. Doesn't that work? If you have twins, hello people, okay, they're going to be the same size and shape, right? So angles opposite them are the same thing. That even goes with our isosceles triangle theorem. Now, obviously, what if I give you angles and I don't give you sides? Could I go the converse version of this and say, hey, look, here's a really large angle. Its side is going to be longer, correct? Think about obtuse triangles. Say that's 100 degrees. What's the longest side in that triangle? The side opposite it, correct? So we actually, and again, I've named this the converse of the 3 Bears theorem, okay? Again, you're not going to ever see this in any textbook. But this time, what it allows us to do, I'm just going to abbreviate that, it allows us to compare angles in order to get a comparison of sides. So let's write this one down. If 2 angles of a triangle, guess what they're going to be? Not congruent. Then the longer side is opposite the larger angle. So here, look at the comparison. We said here, angle Z is the larger one. We got angle Y is smaller. So that means that segment XY is longer. Guys, does that feel like common sense in a lot of ways? And we kind of instinctively do this, but we've never really put it down on paper before. So let's have some fun and bless you. Let's figure this out. Okay, it says write the angles in order from smallest to largest. Now, I'm sometimes really mean on quizzes and tests. Sometimes I'll say, largest to smallest, just to make sure you're reading. Okay, so you guys know me, reading directions, the R word, very important. So with this one, guys, you have just to think in your head, what is going to be Papa, Mama, and Baby, okay? What's the longest, medium, and smallest side, okay? So with this one, isn't this our largest side? Okay, so doesn't that make this one the largest angle? So that's going to be our end one. All right, guys, what's our smallest side? 722. So what ends up being our smallest angle then? Angle F. So that's our first one, angle F. We just have to list them. You don't have to do a comparison. You don't have to write an inequality. I just want you to list them. So I got angle F. Okay, where's Mama Bear? Where's the middle side? Yeah, isn't that going to be 19.6? So isn't this the middle one? Or Mama Bear? What angle is opposite that? Angle H. And then we have our Papa Bear, so we're just going to go back to blue, which is our largest one, be angle G. Guys, what do you think? Hard? All right, you guys do the next one. Go. Do the next one. Wow. Come on, Jean. Again, list the angles of the triangle in order from the smallest to the largest. If you're a visual person, should you draw the diagram? I drew it out. It's not even to scale, but if I trust my numbers, should I be able to figure out which one's which? All right, who's got this one for me? Thinks they got these figured out. Danny. Angle E, angle F. Yeah, so angle E, because it's opposite the shortest side. Then you said angle which one? F. Yep, angle F. And then our largest, or Papa Bear, correct, is 18, so that's going to be angle D. Whew, so hard. Ugh, rough day. Isn't this common sense? Isn't it so cool that segments and sides really do make a difference? So really, it helps us when we're working with stuff. Does this make reasonable answers? My favorite is when hypotenuses are shorter than their legs. Guys, that's not reasonable, all right, of a right triangle. So just make sure you use this to your advantage. All right, let's go use the converse of the three bears theorem. It says write the sides in order from shortest to longest. For those of you who are very visual, what's the one thing you probably want to do to that triangle? Yeah, add the other angle, don't you think? All right, so what is the measure of angle R real quick? What'd you guys get? 48. You got that 180, and you just subtracted the other two, right? So this is 48 degrees. The moment I know that, can I go ahead and match them up? If that 48 is my smallest angle, what's my shortest side? Segment what? PQ. Awesome. Guys, what's going to be my middle side? Which one? Yeah, QR. This is my middle length side because it's opposite the 60, so it's going to be QR. And what's our largest? Yeah, so this is the largest, which is my longest side, so segment PR. Easy schmeezy? All right, do the next one. Let's do the next one. All right, who has this one for me? Lindsay. What is your shortest side? Yep. So it'll be segment EF is your shortest. Yep. Then segment DE. Yep, and segment DF. Yep. Anyone disagree? No. Isn't this such a visual thing? Mark up your diagrams, guys. That's my biggest tip for you. Just mark them up. You'll be okay. All right, let's use this stuff, what we know about triangles. Guys, we know that 3 segments make a triangle. I know you're earth-shattered by that there's 3 sides of a triangle. But do all 3 line segments, if I give you any 3 line segments out there, will they guarantee make a triangle? No, but let's think the common sense part behind the why of this. First of all, it'd be very easy to see how I could form that isosceles triangle right there with the base of 7 and the 2 sides mean 4, because you literally could connect it together like on hinges, right, and put together and you make a triangle. What happens though if I had these 2 sides were both at 3 instead? Would it form a triangle? No, because there's no way they're possibly going to what? Can these 2 possibly intersect if this side is 7? So no, it didn't work. So here's my question. What about one that looks like this? What if this was 7 and this is 3.5 and this was 3.5? Would that make a triangle? All right, imagine it's on hinges. See if I can do this. Here's a hinge here, here's a hinge here. All right, I'm moving them on the hinge. I'm putting them together, so I'm trying to kind of moving them down. What's going to happen if it's at 3.5 and 3.5? They'd eventually just do what? Intersect each other, and they're going to like go at that one point. It would literally just collapse on it. So what's my issue here? The 2 sides can't add up to that 3rd side, right? What's going to happen with these 2 sides? Look here. If the 2 sides were smaller than the 3rd side, did it work? What did these 2 sides have to be? Bigger. Their sum has to be bigger than the 3rd side. If they're equal, will it work? If it's smaller, will they work? No. The sum of 2 sides has to be bigger than the 3rd side. So that is actually called the triangle inequality theorem. Guys, this is an SAT and ACT type questions that show up. I used to give a homework supplement on this that was strictly SAT questions. We'll use those as review, but we're not going to use them as homework tonight, okay? Because I want you studying for your quiz is what I want you to study for. Besides doing your homework, hint, hint, don't forget your homework. But let's write this down. The triangle inequality theorem. This is what it says. The sum of any 2 side lengths of a triangle is greater than the 3rd side. The sum of the lengths of any 2 sides has to be greater than the 3rd. So here's actually the key. You actually have to check all possible combinations to decide if it would make a triangle or not. So with this, any 2 side lengths have to add. Now, so basically it's a quick addition in your brain is what I'm asking you to do. Now, obviously you have to show me work, but that's basically how you can double check these. Now, here's the thing. This right here helps on a lot of problems. This actually helps in the real world. This section right here is just as important as the theorem. A lot of times what happens or what they do on test, or I will ask you, not just they, I will ask you the same type of things. I will give you 2 sides of a triangle and I'll say, okay, what are the possible 3rd side lengths? Well, the possible 3rd side lengths are inequalities. Okay, it's a range. It's a compound inequality. You guys remember the other day? So how do I solve this? Well, let's think about this real quick. If I know the 3rd side, or if I'm looking for the 3rd side, I know the 3rd side has to be smaller than the sum, right? The 2 sides added together. But remember, that side and with either of the other 2 has to be greater than the other side. So I have to use the difference of it. So this would be, let's say, side 1 plus side 2. And this would be side 1 minus side 2. I'll tell you right now, just take the larger side, subtract the smaller one, okay? Make it positive. We don't have negative side lengths. Just always make it work. So that's where I'm getting those. I will get to an example with you guys on this, okay? Let's do some examples with this. And let's do some homework type problems. It says, here's the easy part. Tell whether a triangle can have sides with the given lengths. Explain. Now notice what it says on your homework. I need to see what? I need to see your explanation. You just can't say yes, no. Okay, you just gotta tell me why. On this first one, I have 3 segments, 7, 10, and 19. Can they make a triangle? I heard a what? No. Why did you say no? Yeah, 7 plus 10 doesn't become greater than the third side, right? It's actually less than. So let me show you the quick, easy way of writing that up. Sound like a good idea? All right, so we're going to say no because that should be, look a little bit more like the word because. Okay, because 7 plus 10 is not greater than 19. Because really the triangle inequality theorem says the sum of any 2 sides is greater than the third. Well, is that true? There's your explanation. Remember the slash through it means not, right? When you talk about not equal, you take an equal sign, you put the not slash through it. So that's an easy way of doing it. You only have to show, the nice thing is you only have to show one of those. You don't have to show all 3. But how about the next one? Would those 3 line segments, oh joy, decimals, all right, 2.3, 3.1, 4.6, would they make a triangle? In your head, did you guys quickly add them together? Okay, is that going to have to be basically what you have to show me for your explanation? Yeah, so you're just going to say yes because, and then show it to me really quick, okay? Yes, because 2.3 plus 3.1 is greater than 4.6. We also know 3.1 plus 4.6 is greater than 2.3. Notice I'm just taking the pairs of the sides together. And last but not least, can I have 2.3 plus 4.6, is that greater than 3.1? You have to show me or explain to me that all 3 side combinations work, right? Any 2 sides is greater than the third. Does that make sense? All right, not hard. Hopefully that will be easy parts for you on there. Look at the next one. The lengths of 2 sides of a triangle are 8 and 13 inches. Describe the possible lengths for the third side. Remember, this is going to be an inequality. If I can write inequality correctly. So basically, visual people, here you go. This is 8, this is 13, there's your third side. What does the third side have to be smaller than? Has to be smaller than their what? Smaller than the sum of any 2 sides. So remember, this is your range. We're going to be smaller than the sum, but greater than your what? Greater than your difference. So what is the sum? Well, the sum, that's going to be 8 plus 13. What's going to be my difference in this case? Yeah, I'm going to go 13 minus what? 13 minus 8. Because notice there is no equal to sign on here. X has to be smaller than 21 because remember, 8 plus 13 is 21. And if it's equal, remember how it lands on itself? So it wouldn't work. But I also know I can't have 5 there because 5 plus 8 is not greater than 13. I'd have to have 5.1. Then would it work? Yeah. So this would be your range of possible sides. Let's look at the next one. It says the lengths of 2 sides of a triangle are 22 and 17 inches. Describe the possible lengths for the third side. Do I want to see the work? What do you guys think? Yeah, if you don't need to draw the diagram, that is okay. That does not hurt my feelings. Like this is 22, this is 17. I'll let Y be my third side here. I'm still going to do the range because they didn't give me any other stipulations, okay? So I'm going to have, the third side is going to be between the difference in the sum of the lengths of the sides. What's my sum, scholars? Talk to me. What do I need to do? Yeah, my sum is going to be, right? My third side has to be smaller than the sum of my two sides. So I got 22 plus 17. But it still has to be bigger than their what? Than their difference. Because remember, that third side plus 17 has to be greater than 22. So we're going to go 22 minus 17. So I know my third side is between 5 and... That doesn't really help a lot. Have you noticed? That's a big range. That's almost like an infinite number of numbers between those two that I could actually find. But we have a slight idea what it could possibly be. Yes, ma'am.
Why do we have to add for these ones that have to be greater?
Because that's actually using this part right here. That's the triangle inequality theorem. Because any two sides have to add degree be greater than the third, right? Because remember, going back to this, if they're not greater than that, I can't make a triangle, right? So it's using that triangle inequality theorem. All right, so guys, with this one, we're going to